This is Priyanka. I'm pursuing my degree from PS University in the background of Electrical and Electronics Engineering. I'm intern in MXC Information Technologies under Jayalakshmi ma'am. In this video, I'll be presenting my internship project, that is microwave oven simulation. These are the topics I have learned during the internship. Let's first talk about introduction of C programming. We all know that it is a procedural programming language. It was initially developed by Dennis Ritchie in the year 1972. Its language include low-level memory, pilot development, 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 and this is the structure of C program. And these are the features of C and applications. C is a middle level language, structure oriented language, portable, modularity, and C is faster. Applications: embedded system designing, operating system, compiler design, database management application, gaming application, cloud servers, device drivers. And these are the keywords and categories of the C programming. Now operators. The symbols that tells the compiler to perform certain mathematical or logical manipulations. There are three types of operator: unary, binary, and ternary operators. And type modifiers are short, long, sign, unsigned, void. And these are the compiler branching based on a variable. And loops, it is a block of statement that performs set of instruction. There are three types of loop: for loop, while loop, and do while. Let's talk about overflow and underflow. Overflow occurs when there is the maximum value that a variable can hold. For instance, if an unsigned char variable is assigned the value 256, it will overflow and the value will wrap around to 0. Underflow. Underflow occurs when the result of an operation is smaller than the minimum value that a variable can hold. For example, if a signed char variable is assigned to value -129, it will underflow and the value will wrap around to 127. And these are the declaration for overflow and underflow. Array. Array is a collection of similar data types or collection of similar entity stored in contiguous memory location. Array of character is a string. Each data item of an array is called an element, and each element is unique and located in separated memory location. Each of elements of an array share a variable, but each element having different index number known as subscript. And these are the syntax for array declaration and array initialization. Now we talk about pointers. A pointer is a variable that stores the memory address of another variable. Instead of holding a direct value, it holds the address where the value is stored in memory. These are two important operators that we will use in pointers concept. These are dereferencing operators and the address operators. Dereferencing operator are used to declare pointer variable and access the value stored in the address. Address operator are used to return the address of a variable or to access the address of a variable to a pointer. Endian. Endian refers to the order in which bytes are arranged in memory. Those are classified into big endian and little endian. And null and void pointer. Null pointer is a pointer that is pointing to nothing. A void pointer that has not been initialized to anything is known as a void pointer. Pass by value and pass by reference. Pass by value is when you use pass by value, the compiler copies the value of an argument in a calling function to a corresponding non-pointer or non-reference parameter in the called function definition. Pass by reference. In this method, the address of an argument is passed to the function instead of argument itself during the function call. And pass array to functions. Passing an array to a function allows the function to directly access the modify the original array. In this article, we will learn how to pass arrays to function in C. In C, arrays are always passed to function as pointers. They cannot be passed by value because of the array decay, due to which whether array is passed to a function, it decays into a pointer to its first element. However, there can be different syntax of passing an array as pointers and return an array in C using pointers. One of the most common ways to return an array from function in C is by using pointers. This involves allocating memory for the array within the function and then returning a pointer to this memory. And this is its syntax. Now let's talk about recursive function. A recursive function can be defined as a routine that call itself directly or indirectly. And this is the structure of recursive function. And the static variables. A static variable is a declared using static keyword and have the property of retaining their value between multiple function calls. It is initialized only once and it is not destroyed when the function returns a value. It extends the lifetime of the variable till the end of the program. Constant. Constants are read-only value that cannot be modified during the execution of a program. These constants can be of various types, such as integer, floating point, string, or character constants. They are initialized with the declaration remains same till the end of the program. Strings. A string in C programming is a sequence of characters terminated with a null character. The C string is stored as an array of character. The difference between a character array and a C string is that the string in C is terminated with a unique character. This one backslash and let's talk about storage classes. Storage classes define the lifetime, scope, and visibility of variables. They specify where a variable is stored, how long its value is retained, and how it can be accessed, which help us to trace the existence of particular variable during the runtime of program. And auto defines a default storage class. Static defines a retains value between function calls. Extern global variables declaration. Register defines suggest storage in CPU register. Now we'll see what is preprocessor directives. Preprocessor program provide preprocessor directives that tell the compiler to preprocess the source code before compiling. All of these preprocessor directives begin with a hash symbol, and the hash symbol indicates that whatever statement starts with a hash will go to the preprocessor program to get executed. We can place these processor directives anywhere in our program. Now, this is the block diagram of preprocessor in C. This is how it executes. Let's see how it works. The process starts with the C source code, which is the human readable code, and the compiler check if the C source code contain any preprocessor directives. As in the last slide I have talked about preprocessor directives. These directives are instruction for the processor which process the source code before it compiled. If preprocessor directive are found, the processor perform the required actions. After processing, the preprocessor generate a modified version of source code which is passed to the compiler. The compiler takes the preprocessed source code and translate it into object code, that is machine readable code. The object code is not an executable, it is an intermediate representation of the program. The linker combines the project code, the object code with libraries and other object files to create the final executable code. Now the executable code is complete program that can be run on the target system. And lastly, we talk about macros. Macro is a piece of code in a program that is replaced by the value of the macro. Macro is defined by hash define directive. Whenever a macro name is encountered by the compiler, it replaces the name with a definition of the macro. Macro definitions need not to be terminated by a semicolon. And this is the preprocessor directive hash define. This is the macro name and this is the macro value. Now up to this we have these are the topics we have learned in the C programming. And let's talk about the project description, abstract of the project. This project is about creating a simulation of a microwave oven, a common household appliances we use every day. The goal is to make the microwave smarter by allowing it to determine the cooking or reheating time based on food status. Rather than just guessing how long it should take, this is done using a real-time temperature monitoring system. In this project, we learned how a microwave oven works and built a prototype that behaves like a real microwave. The entire project was implemented using simulation software, that is PiximLab. Now we'll see the functional requirements for the implementation of the project. On powering the microwave oven, the CLCD displays the power on message, which is followed by the display of 4 different cooking modes. These are micro mode, grill mode, convection mode and start. First, the micro mode. Pressing key 1 now we'll see the first one, the micro mode. Pressing the key 1 in the matrix keypad, micro mode is selected. The CLCD displays the power. CLCD prompts the user to enter the cooking time, that is star button clears the time and hash button confirms the time and start cooking. And now the timer starts and fan starts, and key 4 of the matrix keypad add 30 seconds to the current cooking time. Key 5 pauses the cooking. Key 4 also resumes cooking. Key 6 ends the cooking. And after that it shows CLCD displays the time up and enjoy your meal. And the grill mode, it is same as the micro mode. On pressing key 2 in the matrix keypad, grill mode is selected. CLCD prompts the user to enter the cooking time. Hash button clears the time and star button clears the time and hash button confirms the time and start cooking. And the convection mode. On pressing 3, the matrix keypad, convection mode is selected. CLCD prompts the user to enter the cooking temperature in degrees Celsius. Uh, Star button clears the temperature. Hash button confirms the temperature. Oven start preheating with a given temperature for 3 minutes, that is 180 seconds, following which prompts the user to enter the cooking time. And the start mode, it's same as the it's same as everything. On pressing the 4 key in the matrix keypad, the start mode is selected. Cooking time is set to 30 seconds and the cooking starts automatically. If we keep on pressing start button, it will keep on adding another 30 seconds, another 30 seconds more. And this is up to the requirements for the projects. And now let's see introduction to embedded system. What is embedded system? Any combination of hardware and software which is intended to do a specific task, it can be called as an embedded system. The categories for embedded systems are standalone, real-time. First we'll see the networked and mobile. Standalone, it can work by itself without requiring a host like a computer or processor. For example, domestic appliances such as dishwashers, TVs and digital phones, etc. And our project is also standalone embedded system project. Real time, it is a specialized computing system designed to perform tasks within a defined time constraint. There are two types of real-time embedded system. Hard real-time, three types. There are hard real-time, soft real-time and firm real-time. The system are designed to perform tasks must be completed within a strict frame. That is hard real-time. These systems handle less time critical tasks is a soft real-time. Same as hard real-time, but task as in hard real-time, once a deadline is crossed and the task is not completed, the system fails. But in the case of the firm real-time task, even real-time task, even after the passing of the deadline, the system does not fail. And another two types. These systems are connected to a network which can be either wired or wireless, and they rely on this connection to provide outputs to the other systems or devices. And the mobile, these are portable devices that are designed to mobility and ease of use. And requirements are reliability, cost effectiveness, low power consumption, efficient usage of processing power, efficient usage of memory. And these are the components of the embedded system. First of all, this is the processing unit where the instruction will be processed, and this is the first important part. And next we have memories to store the data. Microcontroller only process digital signals, only it understand 0 and 1. So the sensor will be giving analog signals. We have to convert that analog to digital. For that we have ADC, that is analog to digital converter. Next we have actuators. What is actuators? It is a device that convert electrical energy to mechanical energy. For example, motors. We require analog signals for motors from microcontroller. We cannot microcontroller we cannot send analog signal, so we use digital to analog converter. And next, human interface. This is the human interface which can communicate to the device. For example, display, keyboard, CLCD, switch, etc. And ASIC. ASIC is an application specific integrated circuit. Apart from the microcontroller, we have other ICs like timers, memories. Those ICs will call them as ASIC. And diagnostic part. The diagnostic part is something that is keep monitoring or analyzing. It will monitor whole embedded system. If something is not working, then it will report to the connected system. For example, in industry, if any particular machine is not working, it will send the message to the main system. Their diagnostic port comes into the picture. Now, the auxiliary systems. For embedded system, we need power supply and the cooling system. Why cooling system means semiconductor device, they dissipates heat. If they cross some temperature, it may burn up. So we need cooling systems like heat sinks, fans. Lastly, in order to run all these components, we need software. These all about the component of embedded systems. And now let's see what is microcontroller. An integrated circuit which is capable of being programmed to perform a specific task. The design normally has microcontroller has some restrictions. These are memory size. The memory size will be fixed, it cannot be extended, and the IO capabilities, peripheral functions, etc. And all components, microcontroller mean the all components on a single chip. It has a less design complexity. If we differentiate microprocessor and microcontroller, in microprocessor all are separated components. In the microcontroller, all components on a single chip. In microprocessor, it's more flexible, but it is design complexity. Yeah. Now, host, target, and cross compiler. Host here in the project we are implementing, the host will be MPLAB IDE, where are we gonna write the code. That means the system that is used to develop the target. The target is PiximLab. It's a software that used to simulate it used for simulation, and the board that we gonna use here is PicGenius, and the controller there is PIC16F877A, and the cross compiler, that is X8 cross compiler that we are gonna use. An application used to generate code for another architecture which is in another architecture. The requirements I have already told, that is we need MPLAB X IDE, X8 compiler. In PiximLab we need the controller. This is these are some features of PIC16F877A. It has 40 pins and it has 5 ports in total, that is port A, B, C, D, E, and it has got operating frequency of 20 megahertz, and it has got 15 interrupts and 3 timers, that is timer 0, timer 1 and timer 2, and it has got 8 kilobytes of flash memory and 368 bytes of data memory. And this is the complete block diagram, complete architecture of the PIC16 FA777A controller. And these are the peripherals that interfacing to the microcontroller. To name a few, these are CLCD, matrix keypad, buzzer, LED, digital keypad, and etc. And these are the port configurations. The TRIS registers are, as we said, the ports are, there are 5 ports in the controller. There are port A, B, C, D, E. Here the TRIS registers mean that TRIS registers are a data direction register. What is data direction register? It works as whether the pin should act as input or output. If the TRIS register is attached initialized to 1, it means this is input, it act as input. If it initialized to 0, it is output. And now LEDs. First peripheral will be LED. These are the 2 ways for interfacing a LED to the microcontroller. First, that is current sourcing circuit, and one more is the current sinking circuit. We assume this device as this device is microcontroller. If we assign 1 to the LED, it will turn on and the current will flow from the positive to the negative. That means from the microcontroller to the ground. So microcontroller acting the source of the current, so it is called sourcing circuit. Here from outside the current will flow into the microcontroller. Here microcontroller is absorbing the current, so it is called sinking circuit. And LEDs are connected from RB0 to RB7 and RD0 to RD7, and switches are connected in sourcing circuit manner. And this is a tactile switch. The tactile switch is that one, when you press we will get a sound. For example, it's present in our mouse pad button, mobile phone volume button, increasing or decreasing. These are 2 types of interfacing a switch to the microcontroller. These are sourcing pull-up circuit and pull-down circuit. Why we call this a pull-up? Because when switch is released, pin is connected to the VDD, so it is called pull-up. This one, when switch is released, pin is connected to the ground, so it is called pull-down circuit. Now let's talk about matrix keypad. It acts as an input device, allowing the microcontroller to read multiple button presses from a grid of buttons using only a few input pins. By scanning the rows and columns to identify which key is pressed, essentially providing user input to systems by detecting which button is currently being pushed on the keypad. Now we see the internal structure of the switches, where here 3 columns and 4 rows are there. And how do we gonna check which key is pressed? First we'll check for first key. Whenever we want, like which key we want, that for that we have to assign 0 to that row, and remaining all row we assign 1. Assigning 0 means grounding it. Rest all connected to the VDD. Once which one is pressed, column 1 is connected to ground, and column 2 and column 3 are connected to VDD. So now column 1 becomes 0. This happens when switch 1 is pressed. same as it is all switch all switches are work. And now CLCD is the character liquid crystal display, and there are two types. These are 16 cross 2 and 16 cross 4. It used to display all ASCII characters and symbols, and it has totally 16 interface lines. D0 to D7 are data line. It has built-in controller. It has own RAM and ROM. RS line is register select line. If we if the value is 1 for the register select line, uh, here we are sending the data. If it is assigned to 0, we are sending the instruction. There are two types of communication mode, that is 4-bit mode and the 8-bit mode, and these are the pins that we are interfacing with microcontroller. Now we'll see the interrupt. Interrupts require immediate attention from the CPU. Initially used for emergency event like power failures and system overheating. Concept extended to various subsystems, increasing complexity in interrupt structure. And this one, when the internal or external peripheral device requests processor to stop processing, processor will stop the processing and attend the request and come back where it was interrupted. This is called an interrupt. And here, interrupt service routine. ISR is a software routine that hardware invokes in response to an interrupt. It attends to the request of an interrupting sources by clearing the interrupt flag. It should save register contents that may be affected by the ISR code, and it must be terminated with the RETIE instruction, that is return from interrupt instruction, which tells the CPU to return to the main program. Once the ISR finishes executing, the CPU resumes the main program from where it left off. The system continues running as normal until the next interrupt occurs. This is all about interrupts. And now we'll see the timers. Timer 2. It is a 8-bit timer in the microcontroller. It is used for timing and generating precise delays or PWM signal. It has two key features, prescaler and postscaler, which allow you to adjust the timer resolution and ranges. These are the postscaler and prescaler. The prescaler divides the input clock frequency by a factor of 1:1, 1:4 and 1:16. This allows you to slow down the timer's counting rate, which is useful for longer timing intervals. The prescaler is controlled by this resistor T2 on. Timer 2 register is an 8-bit counter that increment from 0 to 255, and it is readable and writable, meaning you can read its current value or set into a specific value. The timer 2 register is clear to 00H on any device reset. And PR2 register. It is an 8-bit period register that defines the maximum value timer 2 counts up to. When timer 2 matches the value in PR2, it resets to 00H on the next clock cycle. PR2 initialized to FFS, that is 255 upon reset, but you can change it to any value between 0 to 255. Postscaler. The postscaler divides the match output of timer 2 by a factor of 1:1 to 1:16. This allows you to further adjust the timing interval or PWM frequency. The postscaler is controlled by the uh, the register that I have this register timer 2 on and T2 CON, that one, and timer 2 interrupt. When timer 2 matches PR2, it generates an interrupt signal. The interrupt flag timer 2 is set and the CPU can execute an interrupt service routine to handle the event. Timer 2 can be turned off by clearing the timer 2 on bit in the T2 register. This minimizes power consumption when the timer is not in use. And this is all about the topics that I have learned during the internship, and these are the peripherals up to this, and this is the flowchart of my project that I have implemented. First thing, it will be first it displays the screen power on, and it will go to menu screen. In the menu screen, these are the 4 modes, that is micro mode, grill mode, convection mode, and the start mode. And in the micro mode, we have to print these two statements, that is set time and display time. In grill mode, set time and display time. In convection mode, we have to set the temperature and set the time for preheat, and we have to print the display time. And in start mode, as it's same, set time and display time. And this is up to my presentation. Now I'll be giving the demo of my presentation. This is the MPLAB IDE that we are using for the writing code. sound ಕಡಿಮೆ ಮಾಡು. So now we'll clean and build. We had clean and build the program. It's successful right now, and these are the code. These are the files that we had implemented. That is main.c, matrix keypad.c. This is the code. This is the main code where we implemented all the peripherals. And here we had, and this is the main code, and we'll open the PixSimLab. We load the hex file, that is in Emoxy project with micro oven, dist, default, production, and this is the hex file. We're gonna load it onto the simulator. Now the first screen will be powering on, that is microwave oven, powering on the microwave oven. After few seconds, the main menu screen will be displayed. That is these are the 4 modes, that is micro mode, grill mode, convection mode, and the start mode. And if we press the key 1, the micro mode will be selected. If we press key 2, the grill mode will be selected. If we press 3, convection mode, and if we press 4, start mode will be selected. First we'll start the micro mode. As we press the micro mode, the power will display, and here the CLCD will prompt us to enter the user to enter the timings, timings for the heating or cooking. We'll set up to some 20 seconds, and this is the star key. It's for clearing the time that we have entered here. And we press hash. As soon as it will start the timer, and the fan will also start. The key 4 is for resume or start, and fifth key is for pause. We can pause it, and sixth key is for stop. If we press that key, and if we again press start, fourth key, it will resume. And after it reaches to 0, it buzzes the sound, and it will show the time up and enjoy your meal. And the grill mode will be also same, and we see the convection mode. And here we have to enter the temperature. Let's say we'll enter about 120 degrees Celsius. Okay, and enter it, and it will take 60 seconds to preheat. We have declared the maximum temperature as 180 degree, and the preheating time would be the maximum of 60 seconds, that means 1 minute. after 60 seconds of preheating time, it will allow us to enter the timing for the cooking. We'll enter like 2 minutes. Enter. It will start. If we stop and it again will go back into the main mode, menu screen, and the fourth mode is start mode. It is same as that one. As soon as we enter the fourth key, that is start mode, it already entered the 30 seconds before. As we press the start button, it will keep on adding 30 second more, like this. So yeah, 5 pause, it will pause, and 6 it will stop, and it will go back to the main menu screen. Yeah, and this is the reset button. It will again restart from the first. Yeah, this is all about my presentation and the project that I have implemented in the internship. So thank you.